But now, if it's flowing into the ventricles that were relaxed and my pressure was low, it's filling up with blood, what have I now done to the pressure inside my ventricle? I have increased my pressure on the ventricles. And therefore, I'm getting the blood begin to fill up, meaning there's less space. So I'm increasing my pressure. Well, now if I'm increasing my pressure, I'm putting some strain on the muscles. That's going to make those muscles contract. Those muscles have the papillary muscle to the chordae tendineae to the cusp. And if they contract, that makes the cusp do what? Close. So that cusp is going to close, blood's going to fill up, it's going to be under high pressure, and when that contraction occurs, that contraction is going to go whoosh. And depending on which side of the heart we're looking at, it's either going to go into that pulmonary circuit or the systemic circuit. Yes.
Most of that ventricle is more to the system.
Yes. Isn't that kind of cool? So what do we get for the blood flow through these chambers? Follow it. Okay? Now, inferior, superior vena cava. They're my veins. Huge. They are returning blood from the upper portion of the body, from the lower portion of the body. All the veins that we have are going to flow into either the inferior or the superior. And it's going to empty right here into my right atria. So all the blood is going to return to my right atria. So then that blood begins to fill up, pressure low in my right ventricle. We're going to have the blood move through my tricuspid atrioventricular valve, which has its chordae tendineae attached to the papillary muscle attached to the myocardium. So my blood is going to return. It's going to start to fill up my right ventricle. As it fills up my right ventricle, it's going to decrease the pressure in this ventricle. And when my heart contracts, it's going to push this blood from the right atria through the pulmonary semilunar valve into this pulmonary artery. Once we enter this pulmonary, once we go through this valve into my pulmonary artery, I get to what's known as the pulmonary trunk, and it branches left to right because it's going to send this deoxygenated blood into my left and my right lungs, where it's going to drop off all the CO2, pick up the oxygen. As it does that in my pulmonary circuit, it's going to now come back by way of my left and right pulmonary veins All right, everybody following me so far? Now, these left and right pulmonary veins, they empty into my left atria. The left atria now has the oxygenated blood. That's going to begin to get the blood return. My left ventricle will be under low pressure. Blood will move through this atrioventricular valve, which has its chordae tendineae, to the papillary muscle, which is attached to the myocardium, okay? It will begin to decrease the pressure in my left ventricle. From the left ventricle, when it begins to contract, when my heart contracts, it's going to send that blood into my aorta. This is now oxygenated blood. As it enters the aorta, we have branching from the aorta to take it into the neck, the head, upper parts of the body. But the aorta has the aortic arch, and that will begin its descent down the body into the systemic circuit, which is going to be carrying oxygenated blood to the capillary beds to drop off all the oxygen at the tissues, pick up the waste, and return and start the process all over again. This is one beat. Goodbye.
The valve.
The left. Did I call it try?
No, I didn't hear you call it one or the other. I was running it out.
Well, the right is the tri, the left is the bi. The mitral.
Okay.
Yes. And it doesn't separate out. It does this together. So as the atria fill, ventricles fill, heart beats, it's doing this in one beat. Wow. That is the blood circulation for the heart to everywhere else in the body. Now the heart has to have its blood supply. This is our coronary circulation. What is the importance of the coronary circulation? I want to get blood to the muscle of my heart. When someone says, I had a coronary, what did they just tell you? What are they telling you? I had a what? I had a heart attack. A heart attack is the disruption of the coronary circulation. It's not something that occurs inside the heart with the blood flow. No. When someone has a heart attack, it is dealing with the blood flow on the outside of the heart. It means there was a disruption. Blood did not get to the tissues of the heart and those tissues died, and their heart stopped in some way. Does that make sense? Now, the coronary circulation. If someone says, I had a bypass, I had a double bypass, I had a triple bypass, I had a quadruple bypass, what are they telling you? Huh? What has happened to the blood flow of the chambers of the heart? Look at your heart. Follow and trace what it looks like you have for sections of this blood flow. Does it not look like you've got 4 sections for this blood flow? So if somebody tells you, I had a bypass, that means somewhere they had to go in and they had to reroute in one spot of this heart the blood flow. If I had a double bypass, how many areas did they have to reroute? If I had a triple, if I had a quadruple, I had to do the whole heart. They go in and they'll take an artery that's working, and the part of the heart that got affected, that muscle died. That's what's meant by a myocardial infarction. When you hear the term infarction, that's telling you something died. In the terms of myocardial infarction, that means tissue of the heart died. And what they'll do is they'll take an active blood supply and route around it to the other cells beside it so that they work more efficiently.
I'm confused. You just said that if somebody has an MI or heart attack,
Coronary.
it happens outside the heart.
Yes.
But you just said that they took, when they had a heart attack, they go in and,
All they do is open the chest.
oh, okay.
They're simply working on the outside of the heart.
Okay.
And what they'll do is they'll take a blood supply that's working, and let's say this is the area of the tissue that stopped working. They'll take that blood supply and route around it.
So some people don't make it out of the house, so they just die.
When they die, there is an area, it's called the widowmaker, okay, that if that blood flow stops at that point, that's it. There's no return from that. Now, people can have massive heart attacks, but it's not at the area of the widowmaker, and they can survive if they get help soon enough. And most likely they'll go in, they'll get all the cardiac medications, be sent through like the thing that goes in and looks around it. Huh? No. The what?
Catheter?
The catheterization. Okay, they'll go through the catheterization, and then they'll find out how many blockages they have. And if they can't correct any of those blockages with like the roto-rooter or the little spring thing or whatever, they'll know they got to go in and do the surgery. So, yeah. So that's the coronary circulation. So when the heart beats, when we think about what's going to take place inside the heart for that contraction and that movement of the blood flow, there's going to be a part of it that has to work to make the blood flow around the heart, the coronary circulation. When we begin to look at this blood flow, we're going to see that we move quite a bit of fluid, all right, per minute, all these little beats. And have you ever checked like your and I can't believe I forgot my Fitbit this morning. I can't believe I forgot that.